We're back again, and today we're going to introduce four more sorting algorithms. Okay, last time we did three, which was bubble sort, insertion sort, and quick sort, and today we're going to introduce four more, which are heap sort, shell sort, merge sort, and bucket sort. Okay, so without further ado, let's just begin with the heap sort. Okay, there it is. So here's the video. Okay. I sometimes I like to use a visual illustration to basically demonstrate how like each algorithm works, because it's just easier for me to explain. Also, you'll see why like I use this thing instead of like just going to the coding like straight away and just show you how it works. But sometimes using visual helps a lot. Okay. So first of all, what is a heap sort? So heap sort is an algorithm that built upon using heap, okay? Built upon using heap with a given element. So in this case, we're going to build a max heap. We can use minimum heap and whatever, but max heap is what we use a lot in this algorithm. So let's see how it works. So assume that you have this original array, which has 5 sizes and from 0 to 4 index. Um, So firstly, what you want to do is going to build the heap, okay? So how you build the heap? So basically, unlike the binary search tree, so basically this is also a binary search tree, but instead you're not going to like sort it immediately, like we did last time. Like if the element that are smaller than the root element is going to the left, if it's bigger to go to the right. It's not like that. It's going to build it like step by step, level by level, where the root is always going to be index 0, whereas 10 index 1, 2, and then 5 is 3, 1 is 4, and you get the idea. And then after that, you're going to transform this thing into a max heap. So how do you build a max heap? A max heap is when the parent node is always greater or equals to the child nodes. So in this case, let's say 10 is the parent node of 5 and 1, right? So 10 is already a max heap, so you don't need any like swapping. So you'll see it later. 10 is already largest, so it doesn't need any swapping, and then it's going to check 4 since 4 is parent element of 10 and 3. But 4 is not the largest, so 10 is the largest, so it's going to switch place at 4. And after that, it's going to check 4 and 5, so 5 is the biggest, so it's going to swap places. And then after that, if the heap is already built, if the parent elements are the largest, it's going to swap the first and the last and the first index all together, which means it's going to swap 10 and the 1 here. And then you're going to remove 10 from the node, from the tree. So, and then this process will keep on repeating and repeating, and you get the idea. So you have to first of all, calculate the largest element in the root, okay? Put in as the parent element, and after that, when it swap places, it's going to remove that node from the tree itself. So the process is going to repeat until there is only a node left, and then this array is already sorted. Okay, it's going to swap places, and then after that, it's going to, since 3 is the largest already, so it doesn't need to be swapped. So, and then from the right to left, okay, from the right to left, it's just going to swap places. So how do we implement this thing in code? So let's say you have a vector right here, which is unsorted. So this is the original array. And then I'm not gonna go and explain this function, like display function, and what we're doing here again, because since the last video I've already explained it. You can go ahead and watch the last video if you want it. But today we're just going to implement the algorithm, okay, the algorithm itself. So first of all, we're going to have a function called heapify, and then all right, we're going to have these, and then we need a size as well, size, then int I, which is the index of the root element. So this is the reason why I'm not going to like go to coding straight away right now, because heapify is not the function that you call first. So basically you call the heap sort function, right? And then heap sort function will call heapify. So this thing is just like the function to basically sort the algorithm itself. So that's why if I'm going this thing first, if I'm just talking you know back to front, and that doesn't make any sense for all of you. So that's why I decided to use illustration to explain the algorithm instead. Since our code is running top to bottom, that's why I have to do this thing first, because in a method, I'm gonna call this thing heap sort here, which will utilize this heapify, which will utilize the heapify. Heapify has to go first, otherwise it doesn't call, and it will be runtime error. So that's the reason. So first of all, let's build a so not build, but let's just initialize some of the variables first. Let's just say the largest I'm gonna initialize to I. I is, like I said, is the root, and then you have to initialize left equals to 2 times I plus 1. So what does this line mean? So left is basically the left child. So how do you know that it is the left child? So let's just say, um, let's just pick a number 5, right? So number 5 is index 3. So what is the parent element of 5? We know that 5 is the left child because it is odd number, right? That's why you have to um, times I and then plus 1, because I is basically just the root. So, and then 2 is basically because this is a binary tree. That's why you have to time by 2 and then plus 1. So this is always odd number. So the left child is an odd number and the right child always the even number. But how do we find the parent element of all these things? So let's say you pick 5 as the child element. So to find the parent element, you just have to take 3 divided by 2, right? 3 divided by 2 is 1/2. So you have to floor that 2. Have to floor that number, which is 1. So 1, index 1 is, the value is 4. So 4 is the parent element of this one. So in case you're just gonna talk about this thing first and foremost, just put it at the forefront so that you all understand what I'm trying to do here. So it doesn't matter if you plus 1 or not. It doesn't matter. But since we count from 0 anyway, so you don't need to plus 1. I mean, plus 1 is fine, it's up to you. So right equals to 2 times I plus 1. It's the same thing anyway, okay? After this, we have to go check right now if the left child is larger than root, and what do we do? Left less than size. And then you have to check as well in the array, if array of left less than array of not right but largest. So what do we do here? So we're going to just assign like largest equals to left or left equals largest. It depends on you. And you have to check again if if the right child is smaller than is larger large I can't spell, sorry. If same thing, if right less than size and array right less than array of largest, and what you want to do in here, you just have to set largest to right. And then after that, if all the conditions not met, if there's no left and right child at all, and if the largest is not in the root, what do you want to do just in case of that? So since we have initialized I is the root equals the largest, so you just have to reverse that. So if largest not equals to root, sorry, I, and then what I want to do is, first of all, you want to swap the element, yeah, array at index I, yeah, and then array at the largest, which is the root itself. Recursively heapify the affected subtree, and then it's going to call the function again and again, as you saw earlier in the video. So, and then in the heap sort function right here, first of all, what it's doing is that it's going to build a heap first, okay? Which means building heap, which means just rearrange the vector. So you're going to have a loop for this. Int I equals to array dot size. You divide this thing by 2, and then you loop it until the I is equal to 0, and then I minus minus, and then you're going to call function heapify function, which you're gonna input the array in array size and array I. And then you have to then you extract the element from the heap one by one. Okay, extract it, put into original array, and basically it means this step, it just means sorting. So you have int I equals to array dot size minus 1, and then I should be more than 0 and I minus minus. So you decrement each time. The array, I want to stress on this thing a little bit, array size minus 1, which literally it just means that the last index, okay, because you build the heap, you build or you sort the array from last to the beginning, okay? So which means that this index right here, since the size 5, so the last index should be minus 1, right? So that's the logic behind it. And then here though, the swap here, which just means to move the current root, move the current root to n. So you move the root right here to the root and then to the end of this array right here. That's what it means. And then heapify, you just call max heapify on the reduce heap. Yeah, that's what it does. So let's see. That's all the code for this. So let's see how it works in action. So sorted array. Hopefully my code isn't error or something. Let's see that together. Oh, we do have a little bit of error right here. Let's see what's wrong with that. Less than size array left. Nope, this thing should be more because left child is larger. I don't know why I did that. It was error in the code right there. I think it should work right now. There you go. It's working. Okay, let's go to the second algorithm, which is shell sort function. Okay, sorry, cell sort algorithm. Okay, so let's see the video together how it works. So a cell sort function is when we compare the elements that are distance apart from each other, which means you have to calculate the gap. Okay, so we calculate the gap by each pass, and then we reduce it by 2 from each pass. Okay, that's how it works. So let's just start off with this element right here. So which means if we have the array size of 5, so the gap should be 4, because if you count the gap right here, 1, 2, 3, 4, right? So the gap, and then we start off with the gap with n divided by 2. This is formula to it. Okay, we reduce by 2 each pass. So 4 divided by 2 is 2 in this case. So which means the algorithm works by, you're choosing whatever element you want. You can choose 12 first and compare it to other one. But they choose the middle. It's fine. You can do however you want. So 4, and then you compare it to maybe either 12 or 3. It doesn't matter. But if you like compare to 12 because of 2 gaps, right? You count 2 gaps to the left. 1, 2, so it should be 12. And yes, because of 54 is larger than 12, there's no swap needed. And then because they created a temp variable here to store this thing, it's not swap element where you swap two elements. This thing cannot be swapped because the address of the memory address of each element is kind of different, so you cannot swap. So 2, and then you compare like 2 gaps to the left, which is 34, because 2 is smaller than 34. It has to be swapped, or I should say like shift 34 to the this element, sorry, to the index right here, and 2 is inserted to that index, and 3 is going to compare 54, and then it's going to shift. It's going to change. And then after that, 3 is going to compare with 12 because 3 is smaller than 12, has to be shifted. And after that, the gap will reduces by 2 more, okay? Because initially the gap was 4 and then reduced by 2 is 2, but now it reduced 2 one more time. It's going to be, the gap is now 1. Okay, and then you compare 3 to 2, 2 to 3, doesn't matter. Because 2 is less than 3, it's going to switch places. And there you go, and then you get the idea. It's going to compare until there's the gap is sorted, as you can see here. I mean, the gap is now sorry, the gap is 0, and then if the array is sorted, then it is the end of the code. So that's the logic behind it. So how do we implement this? So first of all, let's have int shell sort. Yeah, shell sort, and then you're going to have array of n r, and then you have I think that's all you need to have. So first of all, you have to start with a big gap, and then you reduce the gap, right? So you have to, let's just call this a gap. You can call I, it doesn't matter, but let's just literally call this a gap. The gap equals to array size. You divide the array size by 2 each time, right? Until the gap is more than 0, and then gap divide and equals by 2, which means each iteration of the loop, the gap will be divided by 2 until it is more than 0. And then you have another nested loop. And by the way, this is not a really like good algorithm. I feel like this is n cubed. So I is more than I equals the gap, and I less than array size, I plus plus. You go through the array each time. So what it does here, going to do a gap insertion sort. Okay, it's going to do an insertion sort with this thing. And then the first gap element are already in the gap, right? And then after, keep adding one element until the entire array is until the gap is sorted. So what you want to do right now, first thing, you have to initialize a temp equals to array of I, and then you just int j, whatever. So here you're going to have a loop, another loop for this thing. So j equals to I, and then j more than the gap, and you have to specify these things. This is really important, okay? J has to be more than the gap, and then J is less than, sorry, array of J, okay, minus the gap itself, because you could go through a gap. It has to be more than a 10, and J minus equals to gap. So that depends on the gap itself. So, and then array J equals to array J minus the gap. And then after that, array J equals to 10. So you set the array index J equals to 10. So I think it should be all for the loop, and then don't forget to return 0. I think you can, sorry, this is a return type function. I forgot about that. So you need to have a return value. So let's see, shell sort array, std, cl sort array. Let's run it together. Oh my God, I don't know what's wrong with me today. So what did I do wrong? So for J equals to I, J more than equals, should be equals to gap here. Let's run it again, shall we? And there you go, it is sorted. Anyway, let's get to merge sort. So merge sort is my favorite sort so far because it is like almost like the best algorithm out there. So let's see, how does merge sort work? So merge sort will utilizes a method called divide and conquer. Okay, a divide conquer algorithm, which means it just divide until it is cannot divide anymore, and then it'll conquer it and then merge it back together. That's how it works. Okay, let's say you have the unsorted array right here, and you have to check if L less than L is the left index, R is the right index. If it less than, because the first left index is going to be index 0, right? And then index 10 here, let's just say this is array size 7, so 7 is less than 0. It is true. If it's true, it's going to divide. So using this formula right here, which it's going to m is, I believe it means middle, equals to left plus right minus 1 divided by 2. So you divide the array into 2 parts. So the algorithm works when you divide it, and you have to check again and again and again. The process repeats because this is a loop, right? If left side equals to right side or not, it's going to check both of these. Okay, 0 less than, of course 0 is less than 4. It's going to repeat, divide it until there's a single block of that array left, and then what's gonna do again after dividing, it's going to merge again. Basically, it's going to compare each block of this thing, which one, because we're doing this thing as the ascending order, you have to compare 30 and 27. So since 27 is smaller than 38, it's going to, this thing get inserted first, and then it's going to compare each block to this block again. Okay, so I think you get the idea right now. And then it's going to, yeah, check 3, and then 9, and 27, 9, 10, 27, and then 82 and 27, 38 by 82, and then, 43, and then it's going to insert 82 is going to be the last one. I think you get the idea. First of all, it's going to divide, and then after it's going to merge that block of array back to the original array. Let's implement the code in it. First thing first, let's have void. Let's call this thing merge. Or you can call, we have another function called, hang on, let me just do this thing real quick. And then have to int left, sorry, we need left, we need mid, and then we have the right. We need another function called void merge sort. This thing will happen first, and this function will call this function. That's why you have to put it on the top. If I have to explain it from top to bottom, you might be confused, what the hell am I talking about? So that's why I decided to, like I said, again and again and again, like all the time, like 20 times already, I think. Because, visual illustration is always the best way to learn. So first thing you want to do is find the sizes of two, I'm gonna call these things subarrays, okay? Subarrays to be merged. This function is the merge function, by the way, if you don't know. So in N1, batch 1, I'm gonna call it. So mid minus left plus 1. And the second batch is right minus mid. So why do we have to plus 1 at the end of this batch here? Let's assuming left is index 0 and the mid is just assuming it's index 5, which means the array has 6, the size of 6, right? So the size of the array is 6, so you have to plus 1. So basically you know that the size of the array is 6. So if you take mid at index 5 and minus 0 is 5, so it doesn't make any sense since, like I said, the size is 6. So if 5, then it doesn't make any sense because you're counting from index 0, So after that, what you want to do is you create temp arrays by creating two vectors. I'm gonna call this vector L of n1 and then L of n2. Yeah, not L, sorry. It should be R, sorry, my brain. And then after that, you're going to copy the data to the temp array first, okay? Temp arrays. So for int I, start from index 0 and I less than n1 and then I plus plus, and what you want to do is you're just gonna set the L at index I equals to array left plus I. And same thing for this one, for int, I'm gonna call this thing J right now. So J equals to 0, and then J less than n2, and then J plus plus. So, and then you initialize R of J equals to mid plus 1 plus J. Okay, this is the right batch, and this is the left batch. Okay, you copy it to temp first, and then after that, you're going to merge the temp back to the array. Okay, so what before I do that, I'm just going to initialize a couple of variables first. J equals to 0. Sorry, don't use the wrong syntax. And then k equals to left or right. It's up to you if you want to sort from descending order or ascending order. I'm going to do left, so need a loop right here while I less than n1 and j less than n2. First of all, if l less than li less than or equals to array r array of rj, you just have to set k here is basically the temp. Yeah, so we initialize to left I plus plus and then k plus plus. So from 0 to 1, so that's just, which basically means, let me show the video again. When you sort it back, so you start from 0, right? So you sort this thing 0 and then you put it back here like this. That's what it means. This is not all. There's one more thing you have to do, okay? There are always like a couple of remaining elements, okay? If there are remaining elements, what you want to do. So while I less than, remember I is the left element and j is the right batch, right? So if I less than n1, so the k here will be increment one by one, and then you copy until it's done. So I think this is done now. And for the merge sort right here, this is a little bit like kind of a little tricky, okay? But bear with me. First of all, you have to check first if the left and the right are less, okay? If left less than the right, and then after that, find the middle point because you divide it first, okay? First thing to do. Basically, this thing will be a base case, so I forgot to tell you about this because we'll be using recursion. So we have to calculate first left plus right minus left, or you could do -1. It's up to you. It's fine. So after you find the middle point, after you divide, and then you have to sort, okay? And then you're going to sort the left and the right, okay? And then after you sort it, you're going to merge them back. That's what it does. So merge here will call this function, which will merge back into the original array. This one will merge sort here will be call its own function right here, and then it's going to call this thing over and over again. You keep on dividing and dividing until there's a single block of array left, and then after that, if if left is no longer less than right, and then you're going to call the merge function. Okay, that's how it works. Let's go merge sort and array size -1 because you start from index 0 to the last index. So std out sorted array. Hopefully I don't do anything wrong here. And there you go. Okay, this is sorted. Good. This time good. All right. So let's go to the last algorithm here, which is bucket sort. Well, I gotta say, the concept here is a little bit like sometimes kind of hard to understand, but I try to break it down as simply as I can. So I have to mention one thing. Bucket sort, you use it to sort the what is it called, like the decimal numbers or floating point numbers. So this will apply some of the sorting algorithm, such as the insertion sort, to sort the elements of each bucket. This will look familiar to you, so let's just go ahead and take a look at it. So suppose that you have this floating points array here, and it is unsorted, right? So the number of elements equals to 10, so we will have 10 buckets from 0 to 9. This will look kind of similar to you because this is similar to one of the videos that we did together, right? This is basically just hashing. So what you want to do is that since the algorithm here relies on the first array will be like 0 0.7, so this is the 7 number right here, okay? 7 will belong to bucket 7, and then 1 belong to bucket 1, and 3 belongs to bucket 3, and then you get the idea. and then you keep on doing, and you see the chaining right here. It's basically kind of like almost similar to linked list, but you could call it linked list as well. But it's just like basically you do hashing, right? And then there's some collision and there's chaining going on. So I think you get the idea. Two will be go to the bucket two, and then after that, it's going to sort each bucket, right? So let's just say it's go through each bucket, and it's each bucket will have its own, let's just say, node, and it's going to sort each node, right? So, and then going to sort after each node sorted, it's going to insert back to the original array, the first from the first bucket to the last bucket. So I think you get the idea here. So array sorted. So how do we implement this? First of all, let's call this so since it utilizes some of the insertion sort as well, so I'm not going to try to explain the insertion sort algorithm, but rather, I'm just going to go ahead and copy this thing real quick. This is the last video. If you really wanted to know what it is, you can like watch my last video of the sorting algorithm 1. So this is basically similar to the last one. So I could like kind of summarize this thing a little bit. So basically what it do is that it's going to create a temp variable, and after that it stores the first or whatever variable in the temp variable, and after that it's going to check each element in that array, and then if it's smaller then insert it that way. So that's how it works basically, this in a nutshell. So I'm not going to detail with it, but I'm rather going to detail with the bucket sort here. So we have to have vector float, okay? Because we're using floating numbers here, so that's why I need float. And array. Let's call this thing array, and then we need the size of it. So first of all, find the maximum element in array. So how you find the maximum element in the array? So I'm gonna initialize float max equals to, this is a built-in function in vector library. So we have max element right here, which we will initialize from the array dot begin until array. It's going to go through these. Okay, going to go through the element, and then it's the max from the beginning until the end. Is going to find the maximum element this way. After that, after you found the maximum element, you're going to build a bucket. So create buckets std vector, and then you're going to have another vector inside it, because like I said, we have chaining. That's why you have to create another layer that this thing will be float, and we're going to call bucket, but size, have initialize size in it as well. And after we create a bucket, I have to put the array element into the respective buckets. Okay, so this thing is basically like kind of similar to hashing. So I'm not going to like go into full detail about this. I think that's fine. So in index equals to you have to, since we're working with float and the index is in, you have to force it to be an int, right? So that's why you need to have static cast an int as well. So you have to specify, otherwise there might be a couple of like errors. So array at index I, that's the formula of it. Then you divide that by max, I believe, by the maximum element that we found, and then you times the size minus 1, the array size minus 1. Okay, sorry, can't do that. Let's have int I equals to 0, I less than size, and then plus plus I, or I plus plus. I think that's fine. Sorry, wrong syntax. So here, bucket at whatever index dot, and then you push back to each bucket. Okay, it's not max, should be array I. So after this, you're going to sort individual bucket. So how do we do this? So for int I equals 0, I less than size, and plus plus I. Okay, and then insertion, we're going to use this insertion sort right here to sort our individual bucket. So, and then you're going to uh, concatenate all buckets from to form sorted array. So I'm just going to initialize index equal to 0, and then this is going to loop through each bucket, and then you're going to sort it. You're going to like insert it into the original array. Okay, so that's how it works. So let's call this together. What is it called? Like bucket sort. since we need to have the array and the size, so I'm going to have RR and array dot size here. After that, sorted array. Let's run it together. Let's see if it's sorted. And boom, there you go. It is sorted. So anyway, that's all for today. I know that it's a little bit long right now because this is like we're like introducing four more algorithms for sorting, and yeah, I hope y'all enjoy this episode together. And I know that it's been a lot of fun for me to make this thing again and again, like discussing the algorithms. But anyway, I'm going to see you in the next episode, and bye.